Hi, everyone. Welcome to Gas Chromatography. Let's jump right in and get started. So, as Angie said, I am Melissa Hill. I am one of the chemistry staff scientists here at Vernier. I've been at Vernier a little over 10 years, and in that time, I've done a lot of professional development workshops for instructors and teachers. I've also focused a lot on product development, so developing a lot of the instruments and sensors that you're using, along with the curriculum and software. Before I joined Vernier, I taught at the college level. So I do have experience teaching at the community college level and at the university level, which has definitely made me pretty well-rounded for working at Vernier. And my cohort here today is Noose, and I'm going to have him introduce himself.
My name is Noose. I taught chemistry and physics in high school for 34 years. I've known David Vernier since 1984. I've been building sensors and using David's software and hardware for over 30 years. A few years ago, they had an opening for a chemist, and then I jumped at the chance to come work here at Vernier. And so I've been doing training and curriculum development and technical support for teachers for almost 5 years now, and every day is exciting. So looking forward to the webinar with Melissa, and I hope we can show you some really cool stuff.
Yeah, just like Noose said, and all the scientists here at Vernier are all former teachers. Well, we are all former educators, so we kind of like to say we're for teachers by teachers. But if we can do anything to make your guys' lives easier, especially in this new world, a lot of you are trying to navigate, that is what we are here for. So hopefully you can take away some lessons from today and use those in your classroom. So just to kind of reiterate some of the things Angie mentioned, please put all your questions in that Q&A feature. Noose and Angie will be answering them as we go. And I'm sure all of you, since a lot of you are probably teaching remotely, are very used to the internet crickets. We don't like them just as much as you don't like them. So maybe try it out right now. Let's see if it works. Throw in a question. Tell us what you're teaching right now. Tell us if you taught with Vernier Mini GC before, maybe what you're hoping to get out of this webinar. All that information is great to know right now so we can adjust as we go. And then Noose will stop me at any time if ever he wants to bring a question to everyone's light, but we might just wait till the end for some of those, depending on what we get. And Vernier webinars are famous for the fact that we like to give away stuff in that webinar. We never want anyone to leave empty-handed, and a virtual one is no different. We have a Google folder that Angie put in the chat there that is jam-packed with videos and sample data and experiment files for you to help teach gas chromatography to your students. We're going to go through all of that stuff so you can see how to best use it. And also in that folder is this presentation that has lots of great links and all kinds of great stuff. And of course, you'll also get a video recording emailed to you. All right. So before we can get into gas chromatography remotely, we need to discover what Vernier has for remote education. And that's probably about the #1 question we get these days. What are your options for remote education? And if I go to our main website, vernier.com, I have this huge banner here that says Explore Remote Solutions. And so I'm going to click on that just to get started. And I'm going to self-select as teaching college today. But if I scroll through this page, I see a lot of webinars and a lot of videos teaching me about the different resources for remote data collection that we have. And I know what some of you may be thinking. You're like, I looked back in May, I looked back in June, that didn't really have an option for me. Keep checking these things. This website changes weekly. And we've added a lot of great new stuff. So I would definitely put it on your roadmap to check about every month if you're users of ours. So this first one here is getting started with Vernier remote learning resources. And this is kind of a generic overview of what we have for you that's going to go into a lot more detail than I am. I'm more focused on chemistry today, but it's a great webinar to get started with. Our brand new resource for remote education is called Vernier Graphical Analysis Pro. And what's really nice about GA Pro is that it allows you, if you, the teacher, are able to go into the classroom or able to do some experiments from home where the students are not, you're able to take that data live, and via internet, your students can see you taking that data live, but then actually have the real data on their end. So it's not just like a Zoom, let me show you the data coming in and give you a file later. It gives the students a lot more context as to what you're doing to get the data for them to see it in order to be able to do data analysis and stuff like that. So that's just one more way to kind of get them to wrap their head around what's happening in an experiment instead of a video of an experiment, a data file. So it's a really great feature. You can also put in videos and sync the data. So if I mix vinegar and baking soda and get some chemical reaction and I'm monitoring the temperature of it, I see exactly when that temperature spiked and what was going on because I have a video of it and I have it synced to the data. So all that is intertwined in that new software. It's a site license. It's a free 30-day trial. Definitely give it a shot. And we're also going to be doing a free webinar that goes through all of its nitty gritty in a few weeks. So we'll be talking about that a little bit later. Vernier video analysis is great for physics teachers. So if you're a chemistry teacher, I know a lot of you also teach physics. If your data is coming from a video, if someone is shooting a basketball and you want them to determine the mass of that basketball, for example, this is what you would use. You get all the data from the video itself. It's also a site license. It has its own free webinar and a 30-day trial. So definitely check that out if that's of interest. Pivot Interactives is kind of its own entity altogether. What's different about it is it has probably bazillion videos, and each video has a different variable. So for instance, if you went into a Pivot Interactives activity about an acid-base titration, you could find 5 different acids that you're titrating, and the student has to manipulate the data and answer all the pre-lab and post-lab based on those different variables. So they could see a strong acid, they could see a diprotic acid, and compare them. So that is a really powerful tool actually for remote learning. We also have activities for Arduino that are totally free. So you chemistry teachers that teach some coding, teach some engineering, look at those free activities. But most of what I'm going to talk about today is our completely free experiment and sample data library. So probably the #1 question I've been asked since COVID started is, what does Vernier have for remote education that is free? And I will point them to this 100% of the time. So this is a fantastic resource and it's 100% free. So this whole page tells you how to use it, but I'm the kind that just clicks through and figures it out later. So we're going to click in, and basically this is a huge Google folder. And up here we have all the subject areas that you might be teaching. I'm going to click on chemistry because it's the best one. And basically what you are looking at now is every single experiment in our chemistry books is listed here. Almost every single experiment is listed here. And the scientists at Vernier went and collected data for every single one of these experiments that we could. And we posted these data files here. So let me scroll down to one that we're going to talk about today. So organic chemistry with Vernier, for example, it's one of our chemistry books. We're going to be talking about synthesizing ethyl acid acetate today through a Fischer esterification. I know I was going to get that wrong, News. He told me to say it 12 times fast, and no, didn't happen. Fischer esterification, excuse me. And in this folder, there are two items. The first one, every single folder has the Word document, so it's the student instructions. So it's a Word document, so you can edit it as much as you want. So if you want to change the focus of the experiment, you can do that. But basically, you can send that to your students. It has the pre-lab in there. It has all the step-by-step instructions of what they would do if they were in the classroom. And then you send them this other file, which is the complete data file. And it's labeled as well as it can, but it's as if the student took the data. So those are the two items if you're in this right column. So the middle column is the software that the data was collected with. So that data was collected with Logger Pro, and I'm sure many of you are familiar with Logger Pro. Logger Pro is not free. It is a site license. And for those of you who don't know how site license work in Vernier land, you pay it once and you get access to it for your entire department or your entire school. So your department if you're at a college, your school if you're at a high school. But it allows you to put Logger Pro on all of your department's computers, all of your students' personal computers, which is a really valuable thing right now. And in order to distribute Logger Pro to your students, if you already have a site license, the best way to do that is to set up an account on our website. If your school has purchased Logger Pro, that's linked to your account, and there's a big old button that says distribute Logger Pro to my students, and you just work with that, and now all your students have Logger Pro. You don't have to make them buy it. You don't have to make them get that 30-day demo. It's just all there for them. So that's how our site licenses work. The other lab we're going to talk about today is chemical isomers, and this is one of our free experiments that came along with the Go Direct Mini GC that I'm going to talk about in a little bit. But it uses a free piece of software called instrumental analysis to take data and analyze data. So because it's free and it works on Windows, Mac, Chrome, iOS, and Android, I want everyone here right now to, I'm going to paste it in here, go to that site and download instrumental analysis to your current platform. Again, it's totally free. You just download it. We're going to try and do a little hands-on activity with some data collection later. It's up to you. You don't have to, but in my experience, it makes webinars a little bit more engaging if I'm doing something with the presenter. So hopefully you'll do that with me. And then that last column there is if there is a video. We've posted it here. Good news for you is that we have videos for today's labs that aren't posted here. They're in that magical Google folder, and it's really great to have videos, as I'm sure you've all discovered. So that is the remote education overview. So see, we have a lot for you there. Now let's get into the topic du jour, which is gas chromatography. Everything I'm going to be talking about today is with the Go Direct Mini GC. Now, the Go Direct Mini GC is the third iteration of the Mini GC. The third iteration of Vernier Mini GCs. And it has a couple of improvements. The first of which, it has built-in Bluetooth, so it can communicate wirelessly to your platform. So through instrumental analysis, Mac, Windows, iOS, Android, Chrome. It can also communicate via USB. So either way, USB or Bluetooth. But the next biggest improvement is that it sees both polar and non-polar compounds. So for the past 10 years, we've been hearing from customers getting a lot of feedback on the Mini GC Plus, which only saw polar compounds, that they really wanted a version of the Mini GC that could see non-polars. So we worked really hard with Seco Science. to modify the detector and modify the column to be able to see both polar and non-polar compounds. You can see a list of all those compounds here on the main page on our website. You can also see sample chromatograms for those different compounds. You can also see the column that's in there and the detector. The previous generation, the Mini GC Plus, had 5 free experiments that came along with it. No exception here. We wrote 5 brand new experiments for the Go Direct Mini GC. And what I like about these 5 experiments is that they have a really wide breadth of interests. The previous 5 were either based on identification or organic chemistry, and real, fundamental organic chemistry. These ones go a little bit outside the box. Some of them have kind of an instrumental analysis type bend to them. So like the second one where you talk about how do I change the temperature of the column? What does that do to the chromatogram? And so you're just teaching kids chromatography at that point, and you're teaching them instrumentation skills in a controlled environment so they don't break anything. But just because I inject more chemical doesn't mean I'm going to get better results at the end. And I always thought that was an important lesson to teach students, no matter what year they're at. If you're going to have them interact with instruments, that's an important thing to learn. So a lot of these labs kind of focus on making Mini GC a little less black boxy. And then we also have some kind of cool examples like that preparation of banana oil. So kind of getting kids involved that are more interested in natural products, or just different slants on organic chemistry and not just synthesis. And then we're going to talk about the chemical isomers one, which has a great environmental chemistry aspect to it. Okay. So as I mentioned, it works with free instrumental analysis. It's also compatible with LabQuest 2 and LabQuest 3 standalone data collection interfaces. So I'm going to show the first experiment with instrumental analysis and the second one with LabQuest 3. And away we go. So the first experiment is experiment 4 in that free book of experiments that come with the Go Direct Mini GC. And this emphasizes how you can use gas chromatography to separate structural isomers, xylene isomers, specifically ortho and paraxylene. So this isn't strictly written as an organic chemistry experiment. It doesn't have you synthesize anything, but it does have you go through and really need to understand the intermolecular forces and the reaction and the reason that certain chemicals come out faster than others based on their interaction with the column. So it's chromatography 101. Noose, I mentioned he did a workshop a couple weeks ago that did some column chromatography. If you're doing a series of chromatography experiments to get your students really engaged in intermolecular forces and really wrapping their head around what all that means, maybe you start out with some paper chromatography and they do some plant pigments and you see nice bands. Then maybe you do a little column chromatography with some Kool-Aid, and you're actually separating big chunks of it that you can see with your eye, do some spectroscopy with. Well, those are all really macro scale. Now we're getting to a micro scale kind of version of it where we're separating individual molecules and molecules that only have the difference between where a methyl group is. So that's a pretty big, a really nice linear transition for students to understand intermolecular forces and to understand chromatography and why it's such a powerful technique that we have at our disposal as chemists. So that's what this experiment is really great at doing. Also because it involves xylene that has a really strong environmental application. People are always looking at concentrations of BTEX and things. So that you can write it up that way as well. And again, going into that magical folder, we have the student instructions written up here. for you. You can hand them to your students. And then instrumental analysis is free. So I pulled it up here and I'm going to connect it to my mini GC, which I forgot to show you earlier, is right here. And so I'm going to click connect an instrument. And you get the instrument number from this barcode right here. You probably can't see because there's a little bit of glare, but it's written very plainly on the instrument itself, and you connect. So I'm connected via Bluetooth. My only cable here is AC power. I don't have to connect to a gas tank, which is really nice as well. It runs off of room air as the carrier gas. Something also nice about the GoDirect Mini GC is it doesn't just give you the detector response like the previous version did. It also gives you a couple of other channels that you could turn on. The one I find most interesting is temperature. This way you can link the temperature ramping or isothermic to when the chemical eluted. So that can be really interesting to look at. You can also enable the pressure channel, but that one should theoretically be very boring because the pressure does not change during our reactions. So you might at best want that for troubleshooting. I'll leave the temperature channel on there and I'm going to go into my gas chromatography. I happen to have opened a previous data set just so it makes things a little bit smoother, but I want to run a sample for you, show you how everything goes. And because it's not super exciting to watch chromatography come alive, I'm going to make the pressure really, really high so we can get this stuff to come out as fast as possible. And I'm going to be injecting a sample of a mixture of hexane, orthoxylene, and paraxylene. And I'm using the 1 microliter Hamilton syringe that comes with the GoDirect Mini GC. You are almost always injecting liquids with this unit, and you're injecting directly into the column through this injection port. So there's this brown bumper on it that sometimes people want to take off. Never, ever, ever take that off. That is required so you don't stick the needle too far into the column. I'm going to pick up about 0.3 microliters of this sample. I'm going to help guide it into the column. And now when I inject my sample, I want to press this big white button, and that's what's going to initiate data collection. Whereas previously you kind of had to inject and be holding your arm to the computer at the same time. But now I has changed. We see data collection coming in. So that's looking really good. So previous to running the sample, the mixture, so what I just did was run a mixture of hexane, orthoxylene, and paraxylene. I would have run known standards. So that's these two samples here. And just so you guys aren't squinting, I want to show you a couple features in instrumental analysis so you can help your students see a little bit better. First, you can go into presentation mode up here and increase the size of the background. I'm going to leave it at 1.25, but definitely play around with that. And if I want to change what runs are being shown, I click on this graph or this axis label over here. I don't know about you, but I have already forgotten which color is which sample. So I'm going to turn on my graph legend. And so now I have my legend for my two known samples. So para came out first, ortho came out second. Something else you could do in an experiment like this is we have kind of a fun little feature called add prediction. And you could have your students, based on the chemical structure of the ortho and paraxylenes and the chemical structure of the column, guess and predict. They may not know exactly when it's going to come out, but I can say, based on the structure, I think my paraxylene is going to come out first. And then I'm going to add another prediction that my ortho is going to come out second. Or maybe I think they're going to come out on top of each other because they have the exact same chemical formula. You know, it's a good way to get your students thinking. And you can always pull those up down here under predictions. All right, so let's go see the status of the run I was doing. Okay, not quite there yet. So you would have run the 2 standards, and then I did happen to run the mixture as well. And so now we know which one came first and which one came second. And I'll go ahead and turn on the one we're doing so we can compare. And some of you may be wondering why I put hexane in the sample. So I always like to put what I call a little calibration standard. I want to spike my sample with a known, relatively inexpensive solvent that will come out very quickly. And it has a very known retention time. So I can always use that retention time and compare it to the actual compound I want to know the retention time of. So in this case, it would be like xylene. Instead of going from the 0 mark where maybe I didn't press the syringe at just the right time or push the button at just the right time, I know exactly where hexane comes out. So then I can compare that to exactly where xylene came out and get a really accurate retention time that's reproducible from unit to unit, from run to run, as long as I'm using the same temperature pressure profile. So that has saved me a lot, especially if you're trying to compare a room's worth of mini GCs with all your students. It's a really good way to make things a lot more reproducible. So here we go. Here we're getting our first peak. So what peak should that be? Throw it in the chat, throw it in the Q&A. What peak should we be getting here first? And then that second one coming out. Yep, that first one should definitely be the paraxylene, and the second one should be the orthoxylene. Why did those elute so much faster than the previous runs? Why did that happen? Anyone have any thoughts? Well, if you'll remember, I was trying to get this data to come out a lot faster, so we wouldn't be sitting here so long staring at it. Yeah, we changed the tempo of the column and we changed the pressure. The pressure we changed much more dramatically. We went from an 11 kPa, which is this stuff, to a 20 kPa, which is this one. But you'll notice we actually lost a little bit of resolution by doing that, by trying to run those things through. This didn't go to 0 very nicely, or it doesn't have a lot of space in between them. Yeah, you could still integrate that and still get a pretty good retention time. But that's one thing to think about when you're just trying to run things through. So I'm glad everyone had such great answers. Everyone knew. All right, well, let me show you in instrumental analysis. You can do a lot of peak integration and analysis directly in the program. So I'm gonna look at my previous one that I ran, and I'm gonna zoom in on it just to make it a little easier to see. And I'm gonna select this first peak and say add peak. And now I have my retention time, I have my area. If I know what this is, I can relabel it. And tab so I can label this my para-xylene. And I've and if I can select my second peak, I know what this is. I can name it my orthoxylene. And the titles come up there. It's real nice and easy. I get my retention times, I get my areas, I get my percent areas. So if you did do a calibration curve or a standard, or if you did a series of calibration standards and wanted to make this really quantitative, you were trying to measure a reaction, you could get some numbers here that meant something. So now we've finished our experiment in separating para and orthoxylene. I'm a student, I want to get this data to my instructor. There's a lot of ways to get data out of instrumental analysis. One, you can just save it as the file format that it's in, and teachers, it's a free software, you can open it in that same file format. But you can also do some exporting. You can export as a CSV, which will take the raw data and put it in a CSV format that you can open in Excel or Google Sheets or Logger Pro, anything else you might want to use. But what I like to use is this graph image. And it takes an image of everything that's going on. So it has these retention times and how I've labeled it as a student. And I'm going to go back to this handy dandy folder. And we've put in here this lab write-up template. And I actually stole this from Noose. He said he used to do it with all his students in his Google Classroom. And it's just a lab write-up, but it's a great way to share data back and forth or lock it down so no one else can edit it. There's a lot of good features about it. Just put in your partners, put in your purpose, your materials, really make sure they've thought about it. But here, data and graphs. I can just go in and insert the graph I just exported. Now I don't know which one it was. This one, I think. Open. Nope, that's the wrong one. Insert. This one. Okay, and you have a beautiful graph there with the retention times and everything. Student did their homework, didn't lie about it. So really good. So hopefully you downloaded instrumental analysis and downloaded that chemical isomers file from that magical folder and got to play around with it and got to actually explore the peak integration while I was doing some of that. If you haven't, feel free to do it right now and look at it closely. All right, so that's kind of showing you again what your retention time should be for your standards versus your mixtures, and you should be able to tell which one's which based on all that information. And you can go on to do, like I said, a lot more applications with that, with environmental and other kind of stuff. So the next experiment we want to do is from our Organic Chemistry with Vernier book. And this is synthesizing ethyl acetate by Fischer esterification. So in this reaction, this is a really well-known type of reaction. In this particular one, we're going to mix ethanol and acetic acid. We're going to heat them up, and we're going to make ethyl acetate. So I have a video of this guy that I made, and I'm going to let you watch it for a little bit, but it's not the most exciting video. It has me putting up all the chemical test tubes. Sorry. And I have sped up a lot of it because of the boringness of it. But just prepping the test tubes. And so I'm following the experiment as written in order to get to do the condensation reaction, the reflux. We do it in a test tube in some water that we've maintained at a certain temperature. And you just put them all in at once. and then you take each test tube out at 20-minute intervals. And then you quench it for 2 minutes. And that's when you run that at through the mini GC to see the progress of the reaction. Now, if you wanted to do a little bit more quantitative work, you could do some calibrations. You definitely want to run known standards, but you could be a little bit more precise about it. But the main gist of this reaction is to just see that product is being formed over the 60 minutes through this Fischer esterification reaction. So that's the video there. And I am gonna take some live data with you on the LabQuest 3. So many of you are familiar with LabQuest 2. LabQuest 3 is our brand new interface. And anything you plugged into an original LabQuest, anything you plugged into a LabQuest 2, you can plug into a LabQuest 3. Very similar layout. All the experiments work the same. The mini GC is compatible with it via USB. So I do have to plug this in via USB. It won't work via Bluetooth just yet. And so I also have my LabQuest 3 plugged into AC power, but it is battery powered. So you wouldn't necessarily have to have it plugged into AC power. And I know that may be hard for you to see. You probably can't see much about what's going on in that LabQuest 3. So I have a piece of software that I like to use when I'm remote teaching called LabQuest Viewer. And this is a teacher's tool that basically emulates the LabQuest screen. So because we're both on the same Wi-Fi network, I can basically get a live stream of what's happening on the LabQuest. In fact, I can even control it from my computer. And again, we want things to go pretty quickly. This time I'm going to be running acetic acid, ethyl acetate, and ethanol, which should go through pretty quick anyways. So I'm just going to ramp up the pressure to 20 kPa and say, go equilibrate. We're using the same microliter syringe. And look, it's already ready to go. Got my green light. I know I can inject. It tells me on the device and in the software. Gonna get, about 0.3 microliters of this. Carefully insert it. Hopefully, let me turn off some of these because it looks like we'll come back to this. So run 7 is the current one that I'm doing. So I want to make sure I want to see that one. I can also modify what runs I'm looking at here by clicking on the all runs, but I can only look at one at a time. So if I want to see ethanol, I click on ethanol and I get to see that peak. Unfortunately, during data collection with the LabQuest, I can't do any analysis directly. I have to wait for it to stop collecting data. But I can pull up the different ones and see where ethyl acetate came out. I can see where my 3 mixture came out. And so this is ethanol, this is ethyl acetate, and this is acetic acid. So over the course of the reaction, you would expect the ethanol to get lower, the acetic acid to get lower, and the ethyl acetate to get higher. This is pretty close to what you see here. So this is test tube 3. So this is after 60 minutes of running the reaction. You still have some ethanol, you still have some acetic acid, but your most prominent peak is from the ethyl acetate. And if I wanted to compare all 3 test tubes, the way to get just 3 and not all of them, so I could just say here, oh, show me all runs, but that gets pretty messy. I can't really see what I'm looking at here. I would rather go in and pick what runs I want to look at. Go to graph options. Test tube 2, test tube 3, and test tube 1. Say okay. And so now I have 3 on there, and you can see the progression. The first test tube was the highest in ethanol, and that went down. The acetic acid peaked in the second tube, and then the third tube was the ethyl acetate peaked. So we followed the progress of the reaction. Again, if you wanted to do some, make this more quantitative, you could do calibration curves and determine the response of the detector and which concentration that is. But let's look. Oh, looks like my reaction's complete, or my chromatogram is complete. Yes, I know there were only 3 compounds in there. And you can also do peak integration in LabQuest 3. So I'm going to show you how to do that. It's the exact same way in LabQuest 2. If you're familiar with it in LabQuest 2, you go to Analyze, Advanced, Peak Integration, Normalized Response, select your peak, say Add. I know this one to be acetic acid. Oh, no, I'm sorry, I picked the middle peak. This is ethyl acetate. All right, and then I can do that for all these peaks. And when I go back, I can click on it, and that data will be right here. Another common question about the LabQuest is how to get data off of it. There's lots of different ways to do it. It has a USB port. You can save to the USB port using a flash drive. You can email it if you've set it up to do Wi-Fi. You can also export as a CSV, so you can open it in Excel or something else. You can also print directly from it to a wireless computer or through a hardwire. All right, so moving right along. That was our Fischer esterification, and all that video and all that data is in that folder for you. So you'll be able to see, you'll be able to hand that out to your students, and they'll get some kind of context for the data you're giving them. All right, so hopefully throughout that whole thing, you were putting questions in the Q&A and all your questions got answered. If you're one of those people like me, you need time to digest and don't necessarily remember everything at every moment, feel free to go to the website. There's a lot of great facts there. You can always call us, ask to speak to a chemist. You can email chemistry@vernier.com. We have a chat feature on our website. We also have some upcoming webinars that may be helpful for you. We're coming towards the end of our fall webinar series. So this is the last chemistry one for the fall. But if I click on fall virtual workshops, I can go in here and see tomorrow there's a physics one on impulse and momentum. And then there's a biology one on Thursday about evolution. This last one here is the one I alluded to before about Graphical Analysis Pro. 3 ways to enliven remote learning with experimentation. So we're really gonna show you all the different ways that that one app can really change the way you teach remotely. Here we also have a whole bunch of our previous virtual workshop videos. So I talked a lot about nooses and intermolecular forces. That one's right at the top. It's a great one. I highly recommend it, especially if you're trying to graduate from paper to column to gas chromatography. These two workshops together work nicely. And then we did some other ones. Chemistry did some other ones previously on acids and bases. We did a titration, and we did a whole series on teaching the electromagnetic spectrum. So a lot of really good stuff in there for chemists, physicists, and biologists. And if you want personalized online training, you can also request that here. But other than that, were there any other questions? Any comments? Anything else I can help answer? Noose, did anything exciting come up?
It was a good question about, well, you did para and ortho. Why didn't you do meta? It's like, I said, well, he could have, I guess.
I'll be completely honest as to why I did not do meta xylene. It is very expensive.
Oh, I didn't know that.
So para and ortho are pretty inexpensive to purchase the standards of them. Meta is not. And so you can do it. You could even get some BTEX standard or kind of an unknown and do something like that. But I based a lot of what chemicals I pick based on expense and ability to get rid of, because those are two of the biggest things for educators these days, is if they can afford it and if they can get rid of it easily. So that's why I just did the two, but you're more than welcome to do meta, especially some places are affiliated with bigger laboratories and have access to different chemicals. So go for it. It should work just fine.
But anyway, yeah, I didn't realize how expensive it was. So that makes makes a good point. So yeah, I'm glad to hear some folks we actually had one, I asked about suggestions for the spring, because folks, we've done a few of these now, and what we'd like to do is line them up with what people would find the most useful. So if you have any suggestions, don't feel obligated to throw something up there right now. We did have one that was concerned about time, and we definitely feel you on that. Trying to figure out if we can do a webinar for the West Coast or the East Coast. We may have to think something different about that, but also topics. What's coming up in your courses in the spring? Are you teaching some electrochemistry? Are you teaching some kinetics? Are you teaching equilibrium? What's coming up, and what could we share with you that might make it a little easier to do that by remote? So if you have any suggestions, or maybe you see a new piece of Vernier equipment out there, equilibrium, please. Yes, we'll do that. Or we'll talk about it for sure. But if you see any Vernier equipment out there that you've never seen before, maybe you just got some and you'd like us to show how to use it to do an equilibrium experiment, for example, we would love to hear that, and so that we can put that in data sets for equilibrium labs. By the way, check Melissa, you showed them, right? The library. There is a couple.
There's some equilibrium ones in there. Let me share my screen again.
LabQuest 3 is sexy. I like that. It has a cool it has a cool touch screen, which is kind of neat. Just use your finger. And it's pretty neat. But
equilibrium. So we definitely have some for equilibrium in here. What is it in advanced chem, right? Yeah, equilibrium constant right there.
Yeah.
So these are with the colorimeter, and it's an AMBL file. So that's a free graphical analysis file, and the experiment right there. We don't have. That one does not have a video with it yet. But
if we do a webinar, there will be a video.
If we do a webinar, there will be a video. They don't get posted here. Only the participants get our fancy videos.
But Melissa is the video queen. She does a great job with videos. So,
it's my new calling, I've decided. It's been a lot of fun.
So. Yeah.
But yeah, there's some equilibrium constant ones in here. Just please like peruse. There's so much in here. There's another one on chemical equilibrium constant and CWB. I think those are a little bit different in the chemicals that they use, but I think they're both spectroscopy based, right?
And there's
yeah,
definitely someone mentioned crystal violet, and those there should be one for AP Chem and one for advanced chem, I believe.
Yeah.
Or is it just maybe chem, just regular chem?
AP Chem is right here, so we definitely have crystal violet, and that one has a video. In fact, crystal violet is one of the sample videos in GA Pro, which actually looks really cool because the video is linked to when the absorbance goes down. So it's really kind of an aha moment for students, which is really nice then.
And Melissa left the test tube set up so that the excess is sitting right there for the students to see. So as the absorbance is dropping, you can see the test tubes are getting clear. So it's kind of a neat connection between the two. By the way, Graphical Analysis Pro, the free version, 30-day free version, you can see all that stuff. And it is fully functional and you can use it with your students. So think about that. You can set up the 30-day free preview on your device and then share the code with your students so that you can try some of the things that we've been talking about, the data sharing over the internet, that sort of thing. Melissa did a great job with the acid-base titration workshop a few weeks back, where the titration came across while the students were seeing it live. She was doing it, they were also getting a copy of the data on their device, or at least the participants. We'd love to demonstrate that with, say, crystal violet in the future, and so that your data would appear, while you were seeing it. So that might be a good one for us to look at. We've also been talking about electrochemistry and what sorts of things could we share with you with electrochemistry. So if you have any interest in that, let us know. We highly want to do workshops that people are interested in. We don't want to, we're so grateful that you all were able to come, and we really want to make sure that our reach is to as many folks as we can. So if you have friends that are teaching chem and they have any questions or would like to see something in particular, please send us a note, chemistry@vernier.com, and say, hey, I'd really like to see you do this. And we'll put that into the planning. Yep. Electrochemistry, and do you want to see
for electrochem already?
There you go. And we've got some cool devices. We just came out with a new one for college, cyclic voltammetry system that is blowing me away, and I'm a former high school teacher. But we also have a constant current system that is amazing for any of those cell setup sort of things where you want to be able to monitor how much current passes through the circuit or the solution. It's wonderful. We have an ORP and what am I trying to say here, Melissa? Oxidation reduction potential. Yeah. And where would you use that? You might explore our site, and particularly the chemistry site, since, as Melissa pointed out, is the best part. And if you see anything in there that you'd really like to either see where we can help you with remote, or you see something like, I own that sensor, but I've never quite understood what to do with it, let us know. We would love to help you with that. I'm talking a lot. Does anybody else have any suggestions? So the question is, go ahead, you answer it, Melissa.
Yeah, so the question is, the user is very new to LabQuest Mini. What is the difference between Logger Pro and LabQuest Mini? So Logger Pro is a piece of software, and LabQuest Mini is an interface. You might be referring to what is the difference between Lab Pro and LabQuest Mini. Because both of those are interfaces. Both of those, you plug sensors into those, and those plug into a computer, and you can use Logger Pro or graphical analysis software to do that. But the way you phrase that question, the Logger Pro is the software and the LabQuest Mini is the thing that you plug into the computer, and then you plug all your probes and sensors into the LabQuest Mini, and then you open Logger Pro software. But if you mean Lab Pro interface, the difference between the Lab Pro interface and the LabQuest Mini interface is very minimal. The Lab Pro interface had a separate AC power supply. So the LabQuest Mini is a lot nicer that it doesn't require that separate power supply. LabQuest Mini will also work with the free graphical analysis, so you don't need Logger Pro for it.
Schools that are switching over to Chromebooks, you can use the Mini with graphical analysis on your Chromebooks. The old interface, the Lab Pro, which is near and dear to my heart, we had 40 of them at my school, requires a computer. So it can only run on a Mac or a Windows computer, and will not work with graphical analysis. So just to be aware of that. See some great experiments listed there. And as much as I love those experiments, I would really like you to tell me which experiments you don't do that you might want to do. Throw some stuff out there. Would you like to get Avogadro's number? And would you like to do that by electrochem? Okay. I think that would be one that might be of interest to some folks. Something else with redox, looking at the redox, the half reactions, and how can we relate that to electrochemistry.
Yeah,
Logger
so
Pro.
someone commented, yeah, that we're trying to go, that Vernier they're under the impression that Vernier is getting away from Logger Pro and going toward graphical analysis. While we're not abandoning Logger Pro, we're still updating it for OSs and things like this. Logger Pro is a computer-only piece of software, and educators, you know better than I do that computers in the classroom are not as common as they once were. Now they're being replaced by Chromebooks and iPads and Android tablets, and there was just no way to put Logger Pro on those. So that was the incentive to go with graphical analysis. Another reason was that Logger Pro was it's a 20-year-old piece of software, is hugely bloated. I mean, you would use the same piece of software to measure something from a gas chromatograph as you would from a force probe, as you would from, a CO2 gas sensor. And that became very convoluted. We were shoehorning stuff in every which way, and it became less intuitive for the user to use Logger Pro. So it was less user friendly, which is never what Vernier wants to do. So that's kind of why you'll see different apps. So you see graphical analysis, but today I used all instrumental analysis because I had a GC. Instrumental analysis also works with our cyclic voltammetry system, and it's going to work with our polarimeter that's coming out soon. But then we also have spectral analysis, which is also free, but it works with our whole suite of spectrometers. So it enables us to tailor the user experience in a much more intuitive and user-friendly way.
The last second here, I want to put a plug in for a book that all of us in the chemistry group are working on called Food Chemistry. And all of those instruments almost all those instruments that Melissa has been talking about will also be used in that book. And that should be coming out in the spring. And it's applications of many topics in a regular chemistry course, but all around food. And so keep an eye out. There's polarimeter experiments in there, spectroscopy experiments in there, temperature, pressure, pH experiments. So it should be a fun thing.
Yeah. I mean, you can't do food chemistry without a polarimeter. I'm sorry. Just can't happen.
What's all this thing about sugars? What are they? What's a sugar?
Yeah, but throw in any last minute questions. If not, you guys know how to get a hold of us. Definitely shoot us an email, give us a call. Come to the GA Pro webinar in a couple of weeks. I'll be there.
Ooh, brandy from wine.
GC analysis of brandy from wine.
The
So
water.
the only problem with doing GC, with using our mini GC on commercial products, particularly alcohols, is it is a large percentage of water. So you would have to really dry out that sample to get an idea of how much brandy was in there if you were trying to look at the different components, the different chemicals in there. But you really shouldn't be injecting more than 5 to 10% water into the mini GC. So we try and steer people away from alcohol use.
We appreciate your coming to the workshop and look forward to seeing you in future workshops. I saw some great ideas and you can bet we'll be talking about them.
Yeah. Thanks for joining us. Sign up for the GA Pro workshop in a couple of weeks. I'll be there. Me. Looking
like,
through that. Oh, do you have a problem with water with ester reaction sample? No, oh, I see, like the esterification. No, the water that's generated in that is not enough to ruin the detector. In fact, the esterification reactions, the thing you have to be a little bit more aware of is how much acetic acid you're putting in there. And when you run a pure run of acetic acid, that's why I try and caution users not to run the pure acetic acid, to run the ethanol, then the ethyl acetate pure, and then run an equal molar sample with the acetic acid in it. But the water in that is not nearly enough to damage the detector. But that reaction, for all the labs we've written, that one can have the most problems with detectors over time, causing them to kind of degrade a little bit. Yeah, you're welcome.
That surprised me when I ran glacial acetic acid in our GC the first time. It's like, what?
Yeah, I try and avoid it. Like if you know the other two compounds, then you can make a mixture of 3 and figure out where the third one comes in. And I do that a lot. Plus it saves time, saves everything.
Yeah.